Okay, so today we're going to talk about trigonometric derivatives. So far we haven't talked about, well, how do you find the derivatives of, sine function, cosine function, etc. So we're going to talk about those. And the first two here we're going to state without proof. And these, of course, are the most important ones. The derivative of the sine function will actually be cosine. And then the derivative of the cosine will be negative sine. And perhaps I will show a proof of this in some kind of companion video at a later time. But really, these can just be taken as assumptions and givens for most Calc 1 classes. So we'll just state them as givens. So these are probably also the ones that you want to remember the most. So if with all 6 trig derivatives, I would memorize these first. And also what you'll notice as well, and this is just due to the linearity of the derivative, if I want to take the derivative of negative sine x, okay, since we can pull the negative outside like this, although I'll put it back in, this necessarily has to be negative cos x. And then if I take the derivative of negative cos x, that has to be, well, negative sine. So this is going to be sine x. So oftentimes the way that I like to memorize this is kind of in a sequence. So if we start by writing sine, and then we write cosine underneath it, and then we write negative sine underneath that, and then we write negative cosine underneath that, and then we can just repeat this sequence over and over indefinitely. The idea is that as you go down this list, this would be the result of taking derivatives. So the derivative of sine is cosine, the derivative of cosine is negative sine, and then the derivative of negative cosine is sine. And you can even almost think that you just go around in a cycle. You go back to sine. So, if I say, what's the second derivative? Remember, we introduced this notation last time of sine x. That's very easily going to be negative sine x. So this is a cyclic process, so it's very, very useful. Now, what about the other 4 trig derivatives? Well, the other 4 can really be derived from the first 2. So the derivative of tangent is going to be secant squared, and the derivative of cotangent is going to be negative cosecant squared. And really, these are actually very much analogous to one another. So that's why I put them together. Notice one has a secant squared and the other has a negative cosecant squared. If you do ever happen to forget, what this rule is, and the rules for sine and cosine, you should actually very easily be able to do this, because we know that the derivative of tangent, I should say tangent itself can be written as sine x over cos x. And we can actually just use the quotient rule here to derive, and some trig identities to derive that this is secant squared. So we're going to just do that really quick. So remember, the quotient rule says low d high minus high d low over low squared, or low d high minus high d low, square the bottom, and away we go. So we want to do something like that. So low is going to be cos x. D high is actually going to be the derivative of sine, which we said was cosine, minus high, which is going to be sine x, and then the derivative of cosine is negative sine x. And then square the bottom, that's going to be cos squared x. Now let's look at the top here. What is this going to become? This is going to become cos squared x plus sine squared x, and then over cos squared x. And now the key here is that if you remember your trig identities, cos squared x plus sine squared x, for every value of x is going to be equal to 1. So this is just going to be equal to 1 over cos squared x. And then 1 over cos is just secant. So 1 over cos squared is going to be secant squared x. And a very similar proof can be done for cotangent as well. It's basically the same thing, except the sines and the cosines are switched. You'll have an extra negative sign somewhere. So it'll be slightly different, but it's still the same proof, just a little bit different, very analogous. Okay? We can also do something similar with secant. We can write secant as 1 over cosine. And again, we can do a quotient rule from here. I'm going to just skip that. We could do the quotient rule using that. And then when you do that and you simplify, you'll get secant tangent. And then the analogous one here for cosecant is it's going to be negative cosecant and cotangent. So when we look at all 6 rules together, I like to think of the derivatives for sine and cosine to be analogous to one another because you get cos and negative sine. Those are the easiest. And then for tangent and cotangent, I just think, well, one's secant squared, and then for the other one, for cotangent, it's going to be the opposite trig function, which would be cosecant squared with a negative. And then secant is secant tangent, so it's the same as secant, but with next to tangent. And then cosecant, it's again, the big thing here is to just notice that there's kind of a symmetry among them. And anytime you have a way in which you can find multiple different ways to help you memorize this, that's going to help solidify your understanding. So, of course, naturally, you're not going to just be asked to find the derivatives of trig functions by themselves because that would only be 6 types of problems and that would be it. Instead, you'll oftentimes be asked to find the derivatives of trig functions in conjunction with another rule. So let's say I want to find the derivative of sine x over x squared. Here we would use the quotient rule, and then we could use that in conjunction with the derivative of sine. So again, low d high minus high d low, square the bottom, and away we go. So low is x squared. D high is going to be cosine x minus, so low d high minus high, which is going to be sine x, d low, which is going to be 2x. So we'll put that in parentheses. That way we just don't confuse it with the x that's right there. And then square the bottom, and away we go. That's going to give us x to the 4th. And again, we can simplify this or clean this up, but I'll leave that as an exercise for you to do. And of course, this will be your answer. So that's all that I need to talk about with trig derivatives for this particular video. So I hope that you found this helpful, and as always, take care.